Hey guys, so today we're going to talk about chapter 10 homework. So I collected a few questions from Google Classroom. I also collected some questions from Remind and added one question that you might not have done yet, but I just want to talk about it, okay, from 10.3. So yeah, let's jump right in. 10.1, number 7 here. 10.1 is all about angles in the circle, okay? So the circle has a center C and radius of 8. It's labeled for you there. And also an angle there, FEG 45. What is the measurement of FCG? FCG. So FCG is here. Okay, so you can see that this angle here and this angle here has the same arc. So that means you can just go 45 times 2 because it doubles. Okay, doubles the inscribed angle. What's the length of the chord FG? So what's the length here? Okay, so basically you know that this is 8 cm. CF is 8 cm, so which is a radius, and this is also radius, so we can see this is also 8, and you just use chord CFG, would just use Pythagorean theorem, so that squared equals to 8 squared plus 8 squared, and you just solve it afterwards. Okay, solve this one and then square root the entire thing. You can get the answer. Okay, so 10.2, this question received lots of questions. So it's just basically a scenario, but it's talking about the same thing. So whenever we have the chord, so just a general rule, okay? Whenever you have a chord, so I'm just gonna write it here. So whenever they give you a circle and they give you a chord, they give you a dot, don't even think about it, draw two lines if it's already not already drawn for you. So draw a perpendicular bisector and connect two lines to make a triangle, okay? So that's every single time. Every time it's like this. These kind of questions you can solve by these kind of functioning lines here that you create by yourself. Okay, so the water here is basically a tube, and tube with water inside, and the water has a length of 34, and the diameter of the tube is 50. Okay, so this is in 3D drawing, so I want to change it to 2D, so I want to just draw a cross section here. It's like that, and that's 34, that's 50, which is the diameter. Okay, so now according to this one here, what we draw is we draw the center, we draw the perpendicular bisector, and we draw the radius. Okay, you can see a triangle forming here. So what are they asking you? What's the maximum depth of the water? So basically they ask you the depth of the water here. So the depth of the water here. Okay, so to ask yourself, do you know the entire length of here? Yes, because that's a radius, that's only 25. Okay, that's just 25 here. If you want to know this part here, you can just go 25 subtracted by this part. But can you know this part here? I'm just going to label it with purple. So 25 minus the purple will give you the answer, okay? So can you know the purple? Yes, because it's within a triangle. We know that this is 9 degrees. We know that this is radius, which is 25 too. And we know that this part is actually half of 34 because we are told that this is 34 and this is a perpendicular bisector. So this plus this will equal to 34. So one part would just be 17, which is 34 divided by 2 equals to 17. Okay. So if you have that number there, you can actually go ahead and solve the purple part because that's part of Pythagorean theorem. So I'm just going to say the purple part, which is x, let's say it's x, okay, squared plus 17 squared equals to 25 squared. That's coming from our right triangle here. So if you solve x, okay, so throw this over to the other side, change it to minus, and square root the entire answer. So whenever you get whatever you get for x, you just go 25 minus whatever you guess for x, well, you will get the answer, final answer. Okay, so all of these problems, when you have something like this, you basically draw the perpendicular bisector, you draw the triangle. Okay, you connect the dots to make it a triangle. It works every time. Okay, so still 10.2. Let's talk about 12 first. I guess it's the same idea because it's all chord problems. A circle has a diameter of 50. Oh, 50 again. A chord is 14 millimeter long. Chord 14 millimeter long. Like that. Okay, what is the shortest distance from the center of the circle to C? This is the center of the circle to the chord. Okay, so it asks you what's the distance here. What's the shortest distance you can get from the chord to C? So this is what you want to get here. Okay, so what do you do first? You draw the perpendicular bisector, which is already drawn for you because they ask you the distance here. And what you need to do is you do connect these two lines to make it a right triangle. Do you know the purple length? Yes, it's 50 divided by 2, which is 25, because that's radius. And here, do you know this part here? Yes, because that's half of 14, so 7. Can you know that part now? Can you know the question mark? Yes, because that's part of the Pythagorean theorem. 25 squared equals to 7 squared plus question mark squared. And then just solve for question mark. Okay, and then you're done. So 14 here. This one here is someone draw a circle with a radius of 8 and he felt that is wrong, so he ripped it, and we want to check the accuracy, whether this circle he drew has a radius of 8 centimeter. So basically this kind of question, they ask you to find the center. Find the center of the circle. So whenever you find this, so if you find the center of the circle, you can just like test the radius whether it's 6 or not, or 8 or not. Okay, so how to find the center then? Using our chord rules. So if you have two chords here, a perpendicular line that bisects it, perpendicular line that bisect it, wherever it intersect will be the circle, will be the center of the circle, and just measure this length here, whether it's 8 or not. Okay, so this kind of question is not really a testable question, but as long as you understand how to use the chord rules, you're good to go. Okay, by the way, this document here I've emphasized a lot of times. Just print it out because it's like a cheat sheet for all your exams. Okay, so these are the chord rules. So 3 of them, if 2 of them are true, then the other one is true. Okay, this is the chord rule, and the above is the tangent rules. That's which belongs to 10.3. Okay, yeah. So 10.3. Okay, a doggy is tied on a leash to the clothesline pole in the backyard. Okay, so basically the range where the dog can walk is basically a circle. Okay, so the leash is 5 meters long, so label it there, 5 meters long, and the pole is perpendicular distance. It's a perpendicular distance of 5 meters from the edge of the house. Okay, so basically it's 5 here too. Yes. What is the distance from the pole to the cat door? This is the cat door. Okay, and the label for you back of the house is 16 meters. Okay, so what we can do is that every time they give you a radius tangent line, what you need to do is just don't think, just do it, like muscle memory, do it, connect the 2 lines and make a triangle out of it. Why? We want to make a right triangle all the time. According to the tangent rule here, okay, a tangent line here of a circle and a radius here will actually form a perpendicular triangle or a perpendicular angle there. What you need to do next is to connect these two so you can solve all the side what's length kind of problem. Okay, so yeah, let's solve it. So if you know that this is a right triangle, and what's the purple part, it's basically 16 squared plus 5 squared equals 2 question mark squared. Okay, and solve it, you're done. So next question. This one nobody asked yet, but it's really worth talking about. So let's talk about it. But you might not be there yet. Okay, so just follow along. All right, find theta, angle theta here. So this angle here for this question. All right, so you can see that from here, the chords are the same. The chords are the same, so this, if this is 55, this is 55 too, because they're equal central angles. Okay, and then you know that from our tangent rule, here is 90 degrees because it's the point of tangent and the radius and the tangent line. Okay, so angle theta would be 90 plus 55 plus theta equals to 180. So it will be 180 subtracted by 90 subtracted by 55. Okay, so here, this one here. Okay, so you know that angle theta is here. And it seems to be coming from nowhere, but I want you to think about it. I want to dissect the problem here. Whatever way you can do it, you have to know like where do you start off from. So first of all, you know that these are complementary angles. If you know the angle of the green one, you can actually go 180 subtracted by the green, give you the purple. Okay, that's one option. Second option is you know this angle or this angle, because since it's isosceles, you can just go that plus that and 180 subtracted by them. Okay, you can get the purple. But which way is better though? Just by looking at it, if you want to know this angle here, does this angle belong to any of the triangles? No, because see, this is a 4 side, this is not a triangle. Just be super careful about it. So this angle is not solvable, so just forget about it. Can you know this angle here? Yes, because you know this is 90 degrees. Okay, because the tangent line and diameter at the point of tangency. So 74 on this angle, 90 on that angle. Can you know this? Yes. Why? Because it's 180 minus 90 minus 74. So whatever you get from here, let's actually calculate it. It actually equals to 16, I guess. Yes. So if this is 16 here, this is also 16. Why? Because it's isosceles triangle. Okay, and you can go, the purple will then be equal to 180 minus 60 minus 60. You just have to label everything on the diagram. Like, you know, from one angle you know the other information, and you know the other information. It's just the science of deduction there. Okay, just be super sensitive about all the tangent lines, all the 90-degree right triangles you can get, or all the isosceles triangles you can get. Okay, yeah, that's it.